Good day everyone. Today I'm going to discuss to you the Module 8 Integrating ICT in Mathematics Teaching under the subject Principles and Strategies in Teaching Mathematics. In our school situation today, we're having our classes through modular and online method due to the crisis that the world is facing right now. These methods were implemented to keep the students safe and prevent the spread of the virus. So I can conclude that ICT is very useful nowadays, especially in teaching and learning mathematics. It is difficult for the student to understand the solving process of the different mathematical equations, especially in calculus subject, if there's no face-to-face or personal interactions between the teacher and learners or learner to learner. In doing so, and to make the teaching learning process in mathematics become easier, we can use the different digital tools that we're going to discuss later. In this video, we're going to tackle the different tools or different digital tools that we can use in teaching and learning mathematics, and the two modes of interaction and communication in online learning. But before we proceed to our topic, I'm going to introduce first myself. Hi, I'm Gladys Irinco, a third-year BA study student major in mathematics, and I'm asking for your attention just for a couple of minutes to watch my video. So let's come now to our topic. Let's define what is ICT. ICT stands for Information and Communication Technology. Information Communication Technology states that it is a broader term for information technology or IT, which refers to all communication technologies including the internet, wireless networks, cell phones, computers, software, middleware, video conferencing, social networking, and other media applications and services enabling users to access, retrieve, store, transmit, and manipulate information in a digital form. Next, there are two modes of interaction and communication in online learning, or simply two modes of delivering e-learning, the asynchronous and synchronous communication system. 8.1 Asynchronous Communication System. Learning outcomes. At the end of this module, the students are expected to number 1, identify the different types of asynchronous communication system. Number 2, discuss how asynchronous communication system facilitate learning in mathematics teaching. So what is asynchronous communication system? An asynchronous communication system or asynchronous e-learning is commonly facilitated by internet communications media such as email and discussion boards. Students do not need to schedule their time around the predetermined plan of the instructor. There is complete flexibility with asynchronous training, which comes in two forms, facilitated and self-paced. Asynchronous e-learning makes it possible for learners to log on to an e-learning environment at any time and download documents or send messages to teachers or peers. In other words, participants communicate at different times from different places using the same communication tool. Asynchronous tools enable communication and collaboration over a period of time through a different time, different place mode. They are useful for sustaining dialogue and collaboration over a period of time and providing people with resources and information that are instantly accessible day or night. In addition, asynchronous tools are helpful in capturing the history of the interactions of a group, allowing for collective knowledge to be more easily shared and distributed. The primary drawback of asynchronous technologies is that they require some discipline to use when used for ongoing communities of practice. Example, people typically must take the initiative to log in to participate, and they may feel impersonal to those who prefer higher touch synchronous technologies. Different types of asynchronous communication tools. Number 1, discussion boards. Discussion boards is useful for dialogue that takes place over a period of time. Drawbacks may take longer to arrive at decisions or conclusions. Discussion boards are available in all learning management systems. Number 2, Weblogs or blogs. It is useful for sharing ideas and comments. Drawbacks may take longer to arrive at decisions and conclusions. Number 3, messaging or email. It is useful for one-to-one or one-to-many communications. Drawbacks may be misused as a collaboration tool and become overwhelming. Number 4, streaming audio. It is useful for communicating or teaching. Drawbacks, static and typically does not provide option to answer questions or expand on ideas. Number 5, streaming video. It is useful for communicating or teaching. Drawbacks, static and typically does not provide option to answer questions or expand on ideas. Number 6, narrated slideshows. It is useful for communicating or teaching just like the streaming audio and streaming video. Drawbacks, static and typically does not provide option to answer questions or expand on ideas. Number 7, learning objects or web-based training. It is useful for teaching and training. Drawbacks, typically does not provide option to answer questions or expand on ideas in detail. Available in all LMS. Number 8, document libraries. It is useful for managing resources. Drawbacks, version control can be an issue unless check-in or check-out functionality is enabled. Number 9, databases. It is useful for managing information and knowledge. Drawbacks, requires clear definition and skillful administration. Number 10, webbooks. It is useful for teaching and training. Drawbacks, not dynamic and may lose interest of users. Number 11, surveys and polls. Useful for capturing information and trends. Drawbacks, requires clear definition and ongoing coordination. Number 12, shared calendars. It is useful for coordinating activities. Drawbacks, system compatibility. Number 13, website links. It is useful for providing resources and references. Drawbacks may become outdated and broken. Next is 8.2 synchronous communication system. Example, instant messaging, Twitter, FB, and Instagram. Learning outcomes. At the end of this module, the students are expected to, number 1, identify the different types of synchronous communication system. Number 2, discuss how synchronous communication system facilitate learning in mathematics teaching. Synchronous communication system. It states that a synchronous communication system or synchronous e-learning involves geographically dispersed students accessing the same website at the same time as an instructor. This type of learning is commonly supported by internet communications media such as video conferencing and chat. The instructor typically drives a slideshow presentation which the students watch while connected to a conference website. Students can ask questions or provide comments through the phone line or through a chat window. In other words, participants communicate at the same time from different locations using the same communication tool. Different types of synchronous communication tools. Number 1, audio conferencing. It is useful for discussions and dialogue. Drawbacks, cost, especially when international participation is involved. Free options such as Skype are now readily available. Number 2, web conferencing. useful for sharing presentations and information. Drawbacks: cost, bandwidth may also require audio conferencing to be useful. Within the state of Washington, a state-supported tool is available. Some LMS employ a built-in solution, and some free tools are available. Number 3. Video conferencing. It is useful for in-depth discussions, with higher touch interactions. Drawbacks: cost, limited availability of video conferencing system. Number 4. Chat. It is useful for information sharing of low complexity issues. Drawbacks: usually requires typing, lower touch experience. This is the common tool that we have right now. Instant messaging. It is useful for ad hoc quick communications. Drawbacks: all users must use compatible system, usually best for one-to-one interaction. Number 6. Whiteboarding. It is useful for code development of ideas. Drawbacks: cost, bandwidth may also require audio conferencing to be useful. Many web conferencing tools include whiteboard features. Number 7. Applications sharing. It is useful for code development of documents. Drawbacks: cost, bandwidth may also require audio conferencing to be useful. Many web conferencing tools also provide this feature. Next is the 8.3 Other Digital Tools. Learning outcomes. At the end of this module, the students are expected to: number 1. Utilize the digital tools to construct communication text samples. Hundreds of digital education tools have been created with the purpose of giving autonomy to the student, improving the administration of academic processes, encouraging collaboration, and facilitating communication between teachers and learners. Among them, the following are the top 11 most popular according to the e-learning industry, that is com.cdn.ampproject.org. Number 1. Edmodo. It is an educational tool that connects teachers and students and is assimilated into a social network. In this one, teachers can create online collaborative groups, administer and provide educational materials, measure student performance, and communicate with parents, among other functions. Edmodo has more than 34 million users who connect to create a learning process that is more enriching, personalized, and aligned with the opportunities brought by technology and the digital environment. Number 2. Socrative. Designed by the group of entrepreneurs and engineers passionate about education, Socrative is a system that allows teachers to create exercises or educational games which students can solve using mobile devices, whether smartphones, laptops, or tablets. Teachers can see the results of the activities and, depending on this, modify the subsequent lessons in order to make them more personalized. Project. This is a tool that allows you to create multimedia presentations with dynamic slides in which you can embed interactive maps, links, online quizzes, Twitter timelines, and videos, among other options. During a class session, teachers can share with students academic presentation which are visually adapted to different devices. Number 4. Thinklink. This allows educators to create interactive images with music, sounds, texts, and photographs. This can be shared on other websites or on social networks such as Twitter and Facebook. Thinklink offers the possibility for teachers to create learning methodologies that awaken the curiosity of students through interactive content that can expand their knowledge. Number 5. TED-Ed. TED-Ed is an educational platform that allows creating educational lessons with the collaboration of teachers, students, animators, generally people who want to expand knowledge and good ideas. This website allows democratizing access to information both for teachers and students. Here, people can have an active participation in the learning process of others. Number 6. Seikey 12, a website that seeks to reduce the cost of academic books for the K-12 market in the United States and the world. To achieve its objective, this platform has an open source interface that allows creating and distributing educational materials through the internet, which can be modified and contain videos, audios, and interactive exercises. It can also be printed and comply with the necessary editorial standards in each region. The books that are created in CK 12 can be adapted to the needs of any teacher or student. Number 7. ClassDu. It is a tool to improve student behavior. Teachers provide their students with instant feedback so that good disposition in class is rewarded with points and students have a more receptive attitude towards the learning process. ClassDu provides real-time notifications to students like "Well done, David," and +1 for working collaboratively. The information that is collected about student behavior can be shared later with parents and administrators through the web. Number 8. EgoClipper. This platform allows teachers and students to share and explore references in the educational material. In EgoClipper, you can collect information found on the internet and then share it with the members of previously created groups, which offers the possibility to manage more effectively the academic content found online, improve research techniques, and have a digital record of what the students achieve during the course. Likewise, it provides the opportunity for teachers to organize a virtual class with their students and create a portfolio where all the work carried out is stored. Number 9. Storybird. Storybird aims to promote writing and reading skills in students through storytelling. In this tool, teachers can create interactive and artistic books online through a simple and easy to use interface. The stories created can be embedded in blogs sent by email and printed among other options. In here, teachers can also create projects with students, give constant feedback, and organize classes and grades. Number 10. Animoto. A digital tool that allows you to create high-quality videos in a short time and from any mobile device, inspiring students and helping improve academic lessons. The Animoto interface is friendly and practical, allowing teachers to create audio-visual content that adapts to educational needs. Number 11. Kahoot. This is an educational platform that is based on games and education and questions. Through this tool, teachers can create questionnaires, discussions, or surveys that complement academic lessons. The material is projected in the classroom and questions are answered by students while playing and learning at the same time. Kahoot promotes game-based learning, which increases student engagement and creates a dynamic, social, and fun educational environment. Next is 8.4 application of the different digital tools for communication skills development in mathematics learning. What is the role of technology in the teaching and learning of mathematics? Effective teachers optimize the potential of technology to develop students' understanding, stimulate their interest, and increase their proficiency in mathematics. When teachers use technology strategically, they can provide greater access to mathematics for all students. Thus, it is essential that teachers and students have regular access to technologies that support and advance mathematical sense-making, reasoning, problem-solving, and communication. Technological tools include those that are both content specific and content neutral. In mathematics education, content specific technologies support students in exploring and identifying mathematical concepts and relationships. These technologies include computer, algebra systems, dynamic geometry environments, and interactive applets, handheld computation, data collection and analysis devices, and computer-based applications. Content-neutral technologies, on the other hand, include communication and collaboration tools and web-based digital media, and these technologies increase students' access to information, ideas, and interaction that can support and enhance sense-making, which is central to the process of taking ownership of knowledge. A number of studies have shown from their findings that the strategic use of technological tools can support both the learning of mathematical procedures and skills as well as the development of advanced mathematical proficiencies such as problem solving, reasoning, and justifying. Next, the summary. Information and Communication Technology or ICT is an essential portion of teaching learning process. Results from several studies indicated positive attitudes of teachers along with the need of the use of the ICT tools for professional development of teachers and increase the performance of the learners as the learners were found motivated by the recent development of the tools. However, the lack of knowledge to integrate the tools, availability of the resources, affordability by the learners, and insufficient teacher training provisions were found as the barriers in the use of the tools. Communicating with mathematical expressions on the internet is not as easy as communicating with regular text, but there are tools that make it possible. Tools are now available, often with no expense, which offer mathematics instructors options for asynchronous and synchronous communication to support collaborations with their students and between students. That's all for our topic for today. Thank you for watching. Stay safe and God bless.